Find all zeros of the function f of x equals 4x cubed plus 23x squared plus 34x minus 10 if negative 3 plus I is a 0. Well, the first thing we need to check is look at these coefficients in our function f. We have 4, 23, 34, and 10. We have actually integer coefficients, which are definitely real numbers. So all coefficients are real numbers. Because of this, we know that if we have negative 3 plus I is a 0, then negative 3 minus I is also a 0. If negative 3 plus I is a 0, that means x minus negative 3 plus I is a factor. And so is x minus negative 3 minus I. Let's distribute this negative sign. I get x plus 3 minus I and x plus 3 plus I. If you notice, both pieces have an x plus 3 and an I. If you look carefully, you see you have x plus 3 in front of both, the I in the back of both, and then the signs in the middle are different. So this looks sort of like a minus b times a plus b. So recall, if I have a minus b times a plus b, that's a difference of two squares, a squared minus b squared. So I can take x plus 3 and square it, put a minus sign in the middle, and square the back term, which is I squared. So I also know that a plus b quantity squared is a squared plus 2ab plus b squared. So this is x squared plus 6x plus 9, and we also know that I squared equals negative 1. So this becomes minus negative 1 or plus 1. So I can rewrite this as x squared plus 6x plus 10. So I know that my polynomial f of x equal 4x cubed plus 23x squared plus 34x minus 10 has this quadratic term as a factor. So let's do some long division and see what I get when I divide. X squared times what is 4x cubed? Well, that's 4x. Then I take 4x and I multiply by every piece here. I'm really doing 4x times x squared plus 6x plus 10. I get 4x cubed plus 24x squared plus 40x. So let's rewrite this under here. 4x cubed plus 24x squared plus 40x. Let's go back to, I guess, elementary school when we first learned how to do long division. Let's say we had 5 and we were dividing 613. We would say 5 times what gives me 6? Well, that is a 1. Then we multiplied 1 times 5 is 5. 6 minus 5 is 1. And then we brought down the next piece. 5 times what is 11? Well, that was a 2. 2 times 5 is 10, and then we subtract. And we kept doing this, right? So at this point, I need to subtract just like I did in elementary school. So when you subtract this, though, we need to make sure we are subtracting the whole thing. So I like to come in with a different color, like a red, and change every single sign. Doing so, the first terms cancel. I end up with what? Negative x squared. Looks like minus 6x, and then just like I did in 3rd grade, I bring down that next term, minus 10. And then I continue. X squared times what is negative x squared? Well, that's negative 1. So then I do negative 1 times each one of these, just like I did earlier. Negative x squared minus 6x minus 10. Then I come through with my red marker and I change every single sign. Get a plus, and a plus. So it looks like I get 0. Remainder is 0. So I can rewrite my original polynomial f of x in terms of x squared plus 6x plus 10, that factor, times the other factor, 4x minus 1. And what were the zeros? Well, when I take each piece and set it equal to 0, this piece we saw negative 3 plus I and negative 3 minus I. If we solve this, we get 4x equal 1, x equal 1/4. So my zeros, x equal negative 3 plus I, x equal negative 3 minus I, and x equal 1/4.